Hi, I'm Globologer, and this is Auromony, my final project for ZKU, which is a bridge between Aurora and Harmony. The architecture of Auromony composed of four major parts. First are the contracts that are deployed on both Aurora and Harmony. Second would be the front end, which enables users to interact with the services. Third would be the router. The router would be responsible for handling the user transactions, mainly the preparation of them and the fulfillment of them. Fourth, last but not least, is the messaging server, which enables communications off-chain between user, aka the front end, and the back-end router. The workflow of a bridge transaction starts with the user broadcasting an auction of a transaction through the messaging protocol, which would be received by different routers. But in this testnet implementation, we have only one router. The router would then communicate with the user submitting a bid to the user front end, where the user can accept the price that is offered by the router and then submit an on-chain transaction. The transaction then leads to an event which is observed by the router through a subgraph, which once confirmed would then submit the router's transaction to the receiver chain. The user can then unlock the fund that is prepared by the router on the receiving chain, and this action of receiving the locked funds would emit another transaction onto the receiver chain, which the router can use to unlock the original deposit by the user on the sender chain. After going through the theory, let's look at what I have hosting right now. So this running instance is the subgraph service. The subgraph service would be the backend service that the router would use to observe the contract changes or liquidity addition or transactions, etc. And this is the messaging service. It's actually a NAS server that enables communication between the router and user on the front end and in the back end. And this, well, you can ignore this error. It doesn't change the function of it. This is the router instance that handles, this is a Docker instance provided by the NXTP team that handles the router itself and also transaction services. Transaction services is a module within the router service that enables the router to communicate with the chain, aka or issue transactions. And this last one is the front-end hosting, which you can interpret it as the SDK part or the front-end part here. Having gone through the design of Auromony, now we can take a look on how the bridging actually works. So this is the bridging front end where the user can interact with the bridging service. And I've minted myself 1,000 test tokens in the faucet below. Now we can start the bridging process. For example, if I would like to bridge 10 test tokens, we will first query the router in the backend for a bid to fulfill this bridging transaction, and we can see that the router has replied with a fee that we would like to take 0.005 test tokens. So we will be estimated to receive 9.995 test token on the receiving network, which we start from the Aurora testnet towards the Harmony testnet. So if we are good with the bid, we can approve the spending of the test token. Upon the approval of the test token, we can then proceed with swapping the tokens, which will be given a summary page about how much we will be receiving on the receiving chain and how much we will be sending on the sending chain. We then hit confirm. which will pop us the transaction, the bridging transaction itself. While we are waiting for the transaction to go through, we can take a look of the user account here. This is on the Aurora Testnet, which is the sending chain. I've transferred myself some testing ETH and minted myself the test token. And this is the approval transaction we just saw of approving the expenditure of the test tokens. Meanwhile, on Harmony Testnet, which is the receiving network, except that I've minted myself some testing one, we don't actually have the test token just yet. So now we can wait for the bridging process to proceed. So now that the bridging process has completed, we can sign the provide a signature for the router/relayer to send us the funds on the receiving network. The bridging transaction would be fulfilled by the relayer on the receiving chain. If we are to check the router account on the receiving chain, we can see that it has submitted the fulfillment transaction on the Harmony testnet, which sends the user account 9.995 test token. If we are to add the test token to MetaMask and switching our network to Harmony testnet, we should now see the 9.995 test token that we have received on the Harmony testnet. I'm Globologer, and this is Auromony.